In the present video, we will discuss the GATE previous problems on single machine scheduling. First problem is following data refers to the jobs PQRS which have arrived at a machine for scheduling. The shortest possible average flow time is dash days. So here given the jobs PQRS along with the processing time. Then we have to determine the average flow time. First we have to determine the job sequencing order based on its processing time. First we have to draw the boxes. The size of the box is equal to the number of jobs. Here number of jobs are the 4. Then box size is the 4. Then observe the minimum processing time. Here minimum processing time is the 9 days for the job queue. So in the job sequencing order, first we have to place the job queue. Next to minimum processing time is the 12 for the job S. So we have to place the job S after the job queue. Next to minimum processing time is the 15 for the job P. Then we have to place the job P after the job S. And last one is the job R. So this is the job sequencing order. Next we have to determine the flow time. For the flow time, first we have to start with the job queue. For the job queue, flow time is the 0 plus processing time. So processing time is the 9. So for the job queue, flow time is the 9. And for the next job, for the job S, flow time is the previous job flow time plus processing time. So processing time is the 12, then 9 plus 12 which is equal to the 21. Next for the job P, for the job P, flow time is the previous job flow time plus processing time, that is the 21 plus 15 which is equal to the 36. Next for the job R, for the job R, flow time is the previous job flow time plus processing time, that is 36 plus 10 to 22 which is equal to the 58. Then we have to determine the average of these flow times. So average flow time will become the, so here n equal to the number of jobs, then 1 by 4 into 9 plus 21 plus 36 plus 58 which is equal to the 124 divided by 4 equal to the 31 days. So answer is the 31. So this question came in the GATE 2017 for the mechanical paper. So next we have to go for the another problem. 4 jobs are to be processed on a machine as per data listed in the table. So in the table it is given the 4 jobs 1, 2, 3, 4 and processing time in the days and also given the due date. If the earliest due date rule is used to sequence the jobs, the number of jobs delayed is option A 1, option B 2, option C is the 3 and option D is the 4. So let's see the solution. So first we have to find out the sequencing of the jobs by the earliest due date. So the sequencing of the jobs in increasing order of the due date we have to arrange by using the earliest due date rule. So first we have to observe the minimum due date. So minimum due date is the 6 for the job 1. So in the job sequencing order, first we have to place the job 1. So next to minimum due date is the 9 for the job 2. Then we have to place the job 2 in the job sequencing order after the job 1. And next to minimum due date is the 17 for the job 4. Then we have to place the job 4 after the job 2 in the job sequencing order. And last one is the job 3. So next we have to arrange the jobs based on this sequence. So 1, 2, 4, 3, and also its processing time is the 4 for the job 1, for the job 2 7, for the job 4 8, for the job 3 it is the 2. Similarly, due date for the job 1 is the 6, for the job 2 9, and job 4 17, and for the job 3 is the 19. So next we have to determine the completion time Cj. So first we have to start with the first job in the job sequencing order, that is the job 1. So for the job 1, completion time is the 0 plus 4, which is the 4. And next for the job 2, completion time is the previous job completion time 4 plus its processing time is the 7. So 4 plus 7 is the 11. Next for the job 4, completion time is the previous job completion time is the 11 plus processing time is the 8, which is the 19. And next for the job 3, completion time is the previous job completion time plus processing time is the 2, which is equal to the 21. So next we have to determine the lateness, which is equal to the Cj minus Dj. So for the job 1, Cj is the 4 and the Dj is the due date is the 6. So 4 minus 6, which is equal to the minus 2. So similarly for the job 2, processing time is the 11, due date is the 9. So 11 minus 2, which is equal to the 2. And for the next job 4, so completion time is the 19 and due date is the 17. So lateness is the 2. And next for the job 3, completion time Cj is the 21 and due date is the 19. So 21 minus 19, which is equal to the 2. So question is asking that number of jobs delayed. So here only first job having the negative lateness, which means it will be finished the earliest of the due date. Remaining jobs will be the delay. So it is the lateness of, it is indicating the tardiness. So which having the delay the due date. So here job 2 is delaying the 2 days and job 4 also 2 days and job 3 also 2 days delaying. So number of jobs delayed is the 3 days. So option C is the correct. So next, let's see the next problem. 4 jobs are to be processed on a machine as per data listed in the table. So in the table it is given the 4 jobs, job 1, 2, 3, 4, along with the processing time and due date. Using the shortest processing time SPT rule, total tardiness is option A 0, option B 2, option C 6, and option D is 8. So first we have to determine the job sequencing order based on the shortest processing time rule. In this rule, the sequencing of jobs in the increasing order of processing time. So first we have to draw the boxes. The size of the boxes is equal to the number of jobs, that is the 4. So first observe the minimum processing time. So here minimum processing time is the for the job 2, that is the processing time is the 2. So first I have to place the job 3 in the job sequencing order. Next minimum processing time is the 4 for the job 1. So next we have to place the job 1 in the job sequencing order after the job 3. And next minimum processing time is the 7 for the job 2. So I have to place the job 2 in the job sequencing order after the job 1. And last one is the job 4. So next we have to change the given table by using the 3124 sequencing order. So here first job sequencing is 3124 and processing time for the job 3 is the 2 and for the job 1 4, job 2 7 and job 4 is 8. And due date for the job 3 is the 19 and for the job 1 is the 16 and for the job 2 is 9 and job 4 is 70. So here I have to determine the total tardiness. Before that one I have to determine the completion time and the lateness. Then I have to determine the total tardiness. So first I have to determine the completion time for the each job. So first I have to start with the job 3. So for the job 3, completion time is the 0 plus processing time, that is the 0 plus 2, which is equal to the 2. And next for the job 1, so previous job completion time 2 plus processing time is the 4. 2 plus 4, which is equal to the 6. Next for the job 2, previous job completion time 6 plus processing time is the 7. 6 plus 7, which is equal to the 13. So next for the job 4, so previous job completion time is the 13 plus processing time is the 8. So total it is the 21. So next we have to determine the lateness. Lateness, which is equal to the completion time Cj minus the due date Dj. So first we have to determine the lateness for the job 3. So for the job 3, completion time is the 2 and the due date is the 19. So 2 minus 19, which is equal to the minus 17. Next for the job 1, 6 minus 6, which is the 0. And next for the job 2, 13 minus 9, which is equal to the 4. And next for the job 4, 21 minus 17, which is equal to the 4. So tardiness is the, we have to consider the tardiness values, only positive lateness values. Here positive lateness values are the 0, 4 and the 4. So this 17 is the negative value. This negative lateness we are not considering for the tardiness. So here tardiness values are the 0 for the job 1 and the 4 for the job 2 and 4 for the job 4. Then I have to take the average, that is the, so 1 by 4 plus, so for the, this one also I have to consider negative value, also have to consider the 0 only. So here 0, 0, 4 and 4. Then I have to take the average. So 0 plus 1 by 4 into 0 plus 0 plus 4 plus 4. So here it is the 8 by 4, that is the 2. But here question is asking the total tardiness. Average value is the 2, but total tardiness is the 0 plus 0 plus 4 plus 4, that is the 8. So total tardiness value is the 8. Option D is the correct. This question is asked in the GATE Mechanical 2010. Let's see the next problem. 6 jobs arrived in a sequence as given below. Here there is given the 6 jobs along with the processing time. Average flow time for the above jobs using shortest processing time rule is option A 20.83, option B 23.16, option C 125, option D 139. So here I have to determine the average flow time by using the shortest processing time rule. So first I have to determine the job sequencing order by using this shortest processing time rule. According to this rule, first I have to observe the minimum processing time. Here minimum processing time is the 4 days for the job 1. So in the sequencing order, first I have to place the job 1 along with its processing time is the 4 days. Next minimum processing time is the 5 days for the job 3. So next I have to place the job 3 along with the processing time is the 5. And next to minimum processing time is the 6 for the job 5. So I have to place the job 5 along with its processing time is the 6. And next to minimum value is the 8 for the job 6. So I have to place the job 6 along with its processing time is the 8. And next I have to place the minimum processing time job, that is the 9 for the job 2. So I have to place the job 2 along with its processing time is the 9. And anyhow last job, that is the job 4, and its processing time is the 10. So next we have to determine the flow time or maybe the completion time. So here flow time, first I have to start with the first job. For the first job, flow time is the 0 plus processing time is the 4. So 0 plus 4, which is the 4. For the next job, processing time is the 5 and previous job flow time is the 4. So 4 plus 5, which is equal to the 9. And for the next job, processing time is the 6 and previous job flow time is the 9. So 9 plus 6, which is equal to the 15. For the next job, so 15 plus 8, which is the 23, and next one 23 plus 9, 32. Next one 32 plus 10, which is equal to the 42. So now we have to determine the average flow time. Average flow time will become the, there is the sixth job, so 1 by 6 into 4 plus 9 plus 15 plus 23 plus 32 plus 42. So which is equal to the 125 divided by 6. It is the 20.83. So option A is the correct answer, 20.83. So these are the GATE previous questions on the single sequencing, single scheduling machine. And thank you.